All right, guys, we're starting page 30 of our notes. So you need to put page 30, okay? And this is 6.3, equilateral. And isosceles triangles. Okay, so equilateral and isosceles triangles. You're going to want a couple different pens or colored pencils in order to do these notes because you're going to want to outline and label things. Okay. All right, so first we'll talk about isosceles, and recall that isosceles means that it has at least two congruent sides. Okay. All right, so let's say this is an isosceles triangle. Okay. An isosceles triangle has at least two congruent sides. So for instance, let's say this side and this side are congruent. Okay. The two congruent sides are known as the legs. Okay, so that's a leg and that's a leg. Okay, so this side here and this side is a leg. All right, the side that's not congruent, that side's considered the base. So this side here, that's the base. Okay, and then with your angles, the angle that's opposite of the vertex, or the angle that's opposite of the base, so here's your base, the angle opposite means non-adjacent. Okay, so you've got three angles, this one, and this one. Okay, these two angles are adjacent to the base. Okay, the angle that's not adjacent to the base, which is this angle here, that's the vertex angle. Okay, so that's the vertex angle. The two angles that are adjacent to the base, they're opposite the legs. So for instance, this angle right here, this angle is opposite this leg. See how it's opposite across from it? And then this angle here is opposite of that leg. Okay. These two angles are known as the base angles. Okay. So the base angles are opposite the legs. They touch the base. They're adjacent to the base. The vertex angle is between the legs. Okay. So let's do an example. Let's say we have triangle A, B, C. Okay. And it says that segment BC is congruent to segment AC. Okay. So first thing I'm going to do is I'm going to mark those two sides congruent. So segment BC is congruent to segment AC. So here's BC and AC. Those two segments are congruent. All right, so what we need to do, we need to figure out which angle is the base angle, or which angles are the base angles. Which angle is the vertex angle? Okay. Which sides are the legs? And then which side is the base? Okay. All right, so the first thing I'm going to find are the legs. The legs are the two sides that are congruent. Well, the two sides that are congruent are this side and this side. So that's BC and AC. So segment BC and segment AC are the legs. Okay. And I'm going to highlight those blue. Okay. So then the third side would be considered the base. So the third side would be this side right here, which is BA. That would be the base. Okay. Now the vertex angle, that's the angle between the two legs. It's the angle that is opposite the base. So here's the base. The angle opposite the base would be angle C over here. Okay. So notice B and A are both a part, angles B and A are both a part of the base. Angle C is not. So it would be the vertex angle. So this orange angle here, C, that's the vertex angle. Okay. And then the base angles would be the other two angles. It's the two angles that are adjacent to the base. They're also opposite the legs. So for instance, angle B is opposite of side AC. So this angle would be a base angle. And angle A is opposite BC, so it's also a base angle. Okay, so angle A and angle B are base angles. All right, so now that you know which ones are considered base angles and the vertex angle, now let's get to the math part of it. And what it says is if two sides of a triangle are congruent, and I'm abbreviating, I'm using symbols, you are more than welcome to. So if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so for instance, let's say we have this triangle A, B, C. Okay, well, and let's say that segment AB is congruent to segment BC. So AB is congruent to BC. Okay, so what that means is if these two sides are congruent, then that automatically makes the two angles opposite them congruent. So the angle that's opposite of AB would be angle C, and the angle that's opposite BC would be A. So that means that angles A and C would be congruent. Okay, and it also works the other way around. If we know that A and C are congruent, then we know that the sides opposite them are congruent. So we would know that AB is congruent to BC. So it's vice versa. Okay, so if the angles are congruent, then the sides are. And if the sides are congruent, then the angles are congruent also. Okay, let's do an example. It says, in triangle DEF, DE is congruent to DF. Name two congruent angles. All right, so first thing I would do is I would draw triangle DEF. So let's draw triangle DEF. And then just label it DEF. Okay, and then I would mark congruent whatever they say is congruent. So they said DE is congruent to DF. So I marked DE and I marked DF congruent. Okay, now it says name the two congruent angles. So what I would do is I would look at what angles are opposite these sides. So if you look at side DF here, the angle opposite of DF would be angle E. So that's this angle. And then if you look at our side DE, the angle that's opposite of DE would be this angle F. So that means that angle E is congruent to angle F. Okay, let's try a little bit more complicated one. Okay. Number 1 says, if HG is congruent to HK, then angle blank is congruent to angle blank. Okay, and it wants us to fill in the blank. All right, so again, the first thing I would do is take my colored pen marker and I would mark HG and HK congruent. So I would mark this angle or this side congruent to this side. Okay, so those are our legs. All right, so then if these are our legs, our base angles are the ones that are congruent. So you have to figure out which angle is opposite these two sides. Okay, well, if I look at this side here, HK, the angle that's opposite of HK would be angle G, this angle right here. Okay, so that would be angle G. Now I look at side GH, and the angle that's opposite of GH would be this angle right here at point K. Now, I cannot just call this angle K because I have this angle here. I also have this big angle and also have the entire angle, which is 180 degrees. So I can't just say angle K. If you recall, whenever this happens, you have to use 3 letters to name the angle. And so I'd have to make sure that K was in the middle. Okay, so K is in the middle. So a point to the right of it or up here would be H. And the other side would be G. So we would have to name this angle HKG. Okay. Number 2. If angle KHJ is congruent to angle KJH, then blank is congruent to blank. Okay. Notice this time they gave us the angles, so let's fill in these angles. Okay, so it says angle KHJ, so I know H is in the center, and K is on one side, and J is on the other. So here's KHJ, so H is between K and J, so that would be right here. And it's congruent to KJH, so J is in the middle, so that would be this angle here. Okay, and now since they gave us the angles, then we have to figure out the sides. Okay, so you need to figure out which sides are opposite these two angles. So here's this angle, and now we're looking at this big triangle here. The side opposite of angle KHJ would be this side right here, KJ. So that's segment KJ. And then the side opposite this angle would be this side here, which is HK. All right, and then the other thing that we're going to discuss is equilateral triangles. Remember that equilateral triangles have 3 congruent sides. Okay, so if I draw an equilateral triangle, okay, all 3 sides would be congruent. So all 3 sides are marked congruent. Okay. All right. So, and something to know about equilateral triangles is that if a triangle is equilateral, which means if all sides are congruent, then it is also equiangular. So if a triangle is equilateral, then it's also equiangular, and equiangular means that all angles are congruent. So it means all 3 of these angles would be congruent to each other. And vice versa. If it's equiangular, then it's also equilateral. Okay. All right, example. Let's say we have an equilateral triangle, PQR, okay, and it wants us to find the measures of angle P, angle Q, and angle R. Okay, and the only thing we know is that right now it is equilateral. All 3 of these sides are marked congruent. Okay, all right, well, we know that if a triangle is equilateral, then it's also equiangular. So since all 3 sides are congruent to each other, that means all 3 angles are congruent to each other. Okay, and we also know from 6.1 from the triangle sum theorem that all 3 of these angles would add up to 180. So let's say, for instance, I don't know what each of these are, but I do know that they're all the same because they're congruent. So let's say that each of these were x. They would all have to be the same variable because they're the same amount. So to find out each angle, the measure of each angle, we would do x plus x plus x equals 180, because the measure of angle P plus the measure of angle Q plus the measure of angle R is going to equal 180. And I don't know what these are. I just know they're all the same. So I did x plus x plus x equals 180. And then we just solve it. X plus x plus x, that would be 3x. Divide both sides by 3, you get x equals 60. Therefore, each angle would be 60 degrees. Okay? So the measure of angle P is 60. The measure of angle Q would be 60 degrees. And the measure of angle R is 60 degrees. Okay, so anytime you have an equilateral triangle, all 3 angles are going to be 60 degrees. All right, let's do an example. We have a triangle. And it is triangle STU. It is equiangular. And TU is 5 centimeters. Okay. They want us to find the length of ST. They want us to find ST. Okay. Well, looking at this, it's equiangular. So if it's equiangular, then we also know that it's equilateral. So we'd mark all of these congruent. So if this side's 5 centimeters, this side would be 5 centimeters, and this side would be 5 centimeters. Okay. So it says find the length of ST. Well, ST would be 5 centimeters. All right, here's another one. Find the value of x. Okay, and it tells me that it's equilateral, and it tells me that this angle here is 2x degrees. Okay, So since it's equilateral, that means it's equiangular, which means all three of these are congruent. And we have already figured out earlier that each of these angles would be 60 degrees. So this 2x would have to equal 60 degrees. So to find x, I would do 2x equals 60, and then divide by 2, and you get x equals 30. So in order for that to be an equilateral triangle, x would have to be 30. All right, let's do another example. It's a little bit more complicated. Okay, so there's that one. The directions say find the values of x and y. Okay, all right, so first thing I happen to notice is that this triangle here is equiangular, which also means it's equilateral. So that means this side, and this side are all congruent. Well, if this side's 4, that means this side's going to equal 4 and that side's going to equal 4. So all three of these sides are 4. Okay, well, if this side equals 4, then that means y would have to equal 4. Okay, so that's just from this first triangle. So this one had to be 4 and this one had to be 4. Okay, now the next thing, to find x. This x plus 1, we can pretty much forget about this triangle now for a little bit. This x plus 1 is talking about LM, this segment here. Well, what I notice about this triangle is that this angle M and this angle LNM are marked congruent. And if these two angles are congruent, then the sides opposite them are congruent. Okay, well, this is N. The side opposite would be LM, so that's this side. And the side opposite of M would be LN, so that's this side. So this side's congruent to this side here. And if you recall, we actually already know the measure of this side, which is 4. So both of these sides would be equal to 4. Okay, so now to find x, it's x plus 1 equals 4. Subtract 1, you get x equals 3. So y equals 4 and x equals 3. Okay, all right, and that's equilateral and isosceles triangles. If you have any questions, you can email me. Make sure you have your notes completed whenever you come to class on Monday. Thank you and have a great weekend.